Today I'll be talking about optimizing your game after it ships. Now, I don't recommend that you do this. You probably should be considering your performance before you ship your game, but shit happens. So this is optimizing your game after it ships. I'm Tony Albrecht. I'm a principal engineer at Riot. There's a subtitle for this talk. It's well, I work fine on my machine. I'm Tony. I've been at Riot now for 8 years. I've worked on, I primarily work on League of Legends. I'm on the engine team for that. I worked on teamfight tactics. I had the pleasure of helping out with the port to mobile of our engine, which was exciting and rapid. There's a whole story behind TFT and how quickly we built that game and released it, and during the pandemic as well, which was pretty impressive. I've also done a little bit of work on Valorant, just on server-side performance. That's a completely different engine, of course. It's Unreal. The thing is, with League and teamfight tactics, the reason we optimize our game after it ships as well as before is because we release every 2 weeks. Every 2 weeks. So this is something that's kind of impossible. When I started at Riot, I thought, yeah, this is ridiculous. Nobody releases a game every 2 weeks. This is just too hard. But we do it. So that's, I think, we do 24 releases a year. So things go wrong. You know, stuff gets through QA that you miss. You can't help that. So you need to be able to react to that when it goes wrong out in the wild. So for normal teams, your releases go something like this. You spend however long building your game. You release it. Congratulations. You're finished. It's time to kick back and party. But then you start seeing like this. Pops up in Reddit or on social media, or just things are going wrong, and you're not really sure why. But your players are complaining. It's even worse when they start inventing their own fixes because you're too slow to release. So this was a quick search on YouTube for FPS drops in League. Now, some of these kind of work. A lot of them are just voodoo. You randomly do this and you put your mouse on the side and the game gets better. But some of them are actually accurate. So you're in a situation, your game's been released, you need to maintain it. How do you deal with all these bugs that have gone through? What do you do? Well, you need to look at what information you have. Now, you've got player feedback, but player feedback is important, but it's ultimately subjective. They are pretty bad at identifying the actual causes of an issue because they don't have all the information. So at Riot, we will post stuff on like a mega bug thread that pops up on Reddit, and we keep an eye on that. But I mean, we have player support that are more player-facing that will go through and collect these bugs. But it'll be stuff like this. You know, the FPS drops hard during the game, and after some minutes, it's impossible to play. I've submitted a support ticket about it, and I've done all possible procedures you can imagine, but it's bugged. Not fixed since 12.11 patch. So, you know, expected result, I do not lag at any point in game. Observed result, I lag in game. Unfortunately, the bug is still on, and it's been many update patches since first complained about it, and Riot haven't fixed it yet. It is amazing this is a thing, yet they blatantly refuse to fix it. Yep, we refuse to fix it. These are the nice bug reports. Yeah. it's a good problem to have, where people want to play your game but are frustrated that they can't. So it's up to us to be able to read this stuff and deal with it and try and improve it. So to optimize something, you must first measure it. So how do you quantify game performance? What does good look like in a game? And this ultimately depends on the type of game you have. But is 60 frames a second? Is that what good looks like for your game? Is it 30? Is it 144 frames per second? Is it something else that quantifies what good feels like? Depending on the type of game, 2 frames a second might be all right. But, it's also on what platforms. If you're playing on some ancient Chinese Android phone, is it okay to run at 10 frames a second? If you're running on the latest, iPad Pro, should that be running at 120? This is something you need to kind of deal with during development. You need to understand what good is and aim for that goal. Have a bar that you can aim for and be able to measure against, so you know when you're hitting your criteria. Like I said, this is a very game-specific metric. We've done stuff like inject frame drops into a game and have people playing it and saying, okay, at what point does a frame drop or is a 50 millisecond stall noticeable in a 60 frames per second game? Is it 200 milliseconds that is noticeable? What feels good? Identifying that and being able to measure it and quantify it against it during the development of the game, so that your QA can actually report on problems that are occurring. So you need to figure out where good enough is. So there's some basic types of performance degradation. We have a single spike. That's obvious. Single spike is often an easy one to identify and an easy one to fix. Somebody's loading a file from disk in the middle of a game, which you shouldn't be doing. And that's clear to identify, to see, and QA can report on it. It's often pretty easy to fix as well. You might have per level or per region performance degradation, which is a little bit trickier to quantify. It depends on how much it degrades, and it's a bit harder to fix often as well. And then you've got your overall performance degradation, which can be just a slight change in performance over the entire game, and that often slips through. You don't see it until it's too late. So yeah, third one's the worst, and it's also one of the most common, because as you're building a game, you're adding more stuff to it. And you add more stuff to it, it gets slower. It's the way computers work, unfortunately. They should get faster with more stuff, but they don't. So let's look at an example. This is from one of the things I love about working at Riot is I get to work on a game that has like broadcast events, like Worlds is on at the moment. This is from Worlds back in 2018. No, LCS match. And Cloud9 reported significant frame drop in the middle of a game. And it's a professional game, so you don't want that to happen. So as you can see, frames per second hit 45. Now, your professional players want at least 144 frames per second. So this is a significant drop. Now, the report was that IGEA, which is the bottom right, you can see a wall of guys. When that alt occurred, it was causing slowdown. So I got called in to try and figure out what was going on. So there's a lot going on there. What I ended up doing, let me see my notes here. The problem here is that 45 frames per second is actually an average of the frame rate over the last few seconds. So at the point that we're measuring this is not the point that the degradation occurred, but it's often the point where the players notice a problem because it feels sluggish. They look at the frame counter and it's like, oh my God, it's slow. What's happening on screen has caused the problem, but it's actually caused beforehand. So what I ended up doing was we have built-in replay recording. So you can play a game, and then when you finished it, you can download the replay, and you can play it back in your spectator view, and you can scrub through it, and you can look at your moments of glory, or figure out if this other person was actually cheating because they were so good. So I was able to grab a replay of this game, replay it back, and identify when the problem was actually occurring. I mean, it's obvious from here, right? I actually had to use like GPA to look at the actual triangles being rendered to figure out exactly what was going on in there. But the fact that I could do that with this was really cool. So once I'd identified that there was definitely a slowdown, because sometimes it's the machine that's gone wrong. There's something wrong there, it's overheating, it's a problem with the GPU, or there's a virus checker running in the background, which you don't want happening in a professional game. So I then built a profile build, and I was able to then profile what was actually going on. And you can see here, is this a pointer? Anyway, down the bottom, Rakan. So what was happening was one of the champions had a trail, and that trail was a nice smooth ribbon. And the problem was that the tessellation of that ribbon was multiplied by the velocity of that particular champion. And that champion had multiple speed boosts on. So we had tens of thousands of triangles being generated. So we spent like 10 milliseconds or so generating the trail for that one thing. Now, that was a problem with the creation of that particle system. We shouldn't have allowed that to happen. And there was also, at the time, there was no real clear way for the artists to know that that would happen either. So, it's understandable to slip through, because you can't test everything. Like, we've got 150-something champions now. They all have multiple abilities, and those abilities compound with other champions' abilities and their items. So there's almost an infinite combination of possible things that can go wrong. So this is great. Okay, I could identify the problem. It was an easy fix. But we can't do this for every single performance degradation that's reported. If a player reports a problem, we can't necessarily grab their replay, take it back, scan through it, figure out what was going on, and fix each individual thing. So how can we automatically catch performance issues? So reporting performance issues is pretty easy for QA. I mean, they know what's good. You can provide them with some frame counters and stuff, and they can figure out what's bad. It's much harder to do after going live. So, what do you report? And where do you report it? And how do you report this information? You could... I kind of like that one, because you're not going to get any reports. I had to write some Visual Basic to make that happen, so I was quite happy with that. So what do you do with the alert information? So you've got to collect the data, obviously. So you need to generate the performance data as, somehow in the actual live build, and you need to collect it during the actual gameplay without impacting the gameplay. You need to send pertinent data to some form of big data repository. There's a lot of solutions out there. At the moment, Riot's, I think we're just using Dratus to report to Honu, which is like a big chunk of data, and then we feed into that, extract information we want into Databricks, and we can then visualize that stuff in like Tableau or something. So I'll show you some of this stuff a little bit later on. So yeah, we need to put this data somewhere where you can query it. You can extract the useful information from it, and then you can alert on it. So you also want to keep lots of data over a long period of time. 2 weeks of data is great, but I like to be able to see how we progressed over the last 2 years. And given that rate of change over 2 years, where do we expect to be in 2 years' time? That allows us to try and help to understand where we need to be focusing our attention in the future. Is there a constant degradation in performance that we're going to need to address soon before it becomes too bad for some of our lower end players? So also a note from personal experience, keep your data collection API generic. Your data scientists and data people like to have the latest and greatest solution, which changes all the time. So if you're having to change your API to feed data out to whatever system they like, you're going to be changing your code all the time. So keeping it high level, changing the stuff underneath so that it's transparent as far as the game's concerned is a good way to go. So basically, you get your client, or heaps and heaps of clients, and they're all sending their data to some global collector. That collector, you're extracting the information you want and aggregating it to a certain extent into a database, and then refine that even more to pull out exactly what it is you need. Bang that stuff into some form of graphing, alerting system, so you can see trends and you can drill down and filter and really dig into what's going on, and then alert on that as well. It's not just your client, it's your server as well. So this is potentially a lot of data, particularly for something like League. So let's look at some actual data. We're going to look at normal League games running on Windows in Riot regions, and this is about 4 weeks worth. So this is frame times, averages for the entire game. Top is CPU, the bottom one's the GPU. Now you can see there's big variation in performance there, all right? You're seeing we're going from, it's about 17 milliseconds up to 20 odd. So we're looking, up to about 22 milliseconds over a month. That looks pretty bad, you know? And there's some really weird spikes and dips as well. So why does the GPU tick up towards the end of the cycle and down at the beginning? Why? This to me is wrong, all right? If I see this type of data, it doesn't make sense. So let's, also I should mention, like you can see the 2-week release cycle in here as well. I've numbered them by patch number there, so you can see when one stopped, one started. It's weird also that in the middle of a patch cycle, we're seeing performance variation as well, because the code hasn't changed, the data hasn't changed. So what's actually going on here? So we need to kind of slice and dice this data a little bit more. So what we're going to do now is actually split it by region. So we're going to have North America separate from Oceania, separate from Korea, separate from Brazil, and this is what we see. You can see some stratification in here, which is interesting, but still there's a lot of variation. So let's cut out most of these and just keep 3 in there to make it a little bit clearer. So you can see top one's got a lot of variation, the bottom one's almost dead flat. This corresponds to the number of players to a certain extent. The more players you have, your averages are going to kind of settle a little bit more. Let's focus in on the middle one. So axes are changing through here. So you can see we're actually looking at much less variation. So it's about, 15 to 25. Well, actually, no. It's still significant variation. Ignore what I said. All right. So what could cause this dramatic variation in frame times? Anybody got some ideas? That can happen. Often that will cause other sorts of subtle crashes and bugs and stuff as well, and that's something we do have to deal with. What's actually going on here is CPU and GPU combinations affect performance. So it's really interesting that the types of CPUs and GPUs have a circadian rhythm. So faster computers will be run by people at certain times of the day compared to slower people at other times of day. And it's actually a nice, almost sinusoidal type of graph. So what we need to do to extract useful information is to plot these combinations. So we could plot every single unique combination of CPUs and GPUs, but we're looking at about 18,000 CPUs and about 5,000 GPUs, 230,000 combinations of these things. That's too many to plot. Okay? So, and some of them, there'll be one person playing with a combination of CPU and GPU. And as much as, we've almost got to the point where, there's 7 people using a particular CPU having really bad problems, and it would be cheaper for us to buy them new computers than it would be to fix the problem. So we need to reduce the number of combinations. We could just plot a select few. We could have like, your high spec, and you can pick, a particular, say Intel CPU with a particular GPU that's quite common. Similarly for your mid spec and your min spec. And I did that for a while, and that's kind of okay. But the distribution of those machines changes over time as well. So if you're keeping data around for a couple of years, the number of those CPUs and GPUs will change over that time as well. So you're going to get some variation through there. Something that's worked quite well for me is aggregating by a performance benchmark. So I've been using Passmark. So what Passmark gives you is users will log onto this CPU or GPU benchmark, or run it on their machine, and that will feed back up to this big database, and you can pay them some money, and you get all the data back. And you can see which ones are the fastest, which ones are the slowest. And there's still, 18,000 different CPUs, but you can then bucket those into chunks of, say, 1,000, and reduce it from 18,000 to, about 30. And that's where you can start to actually, plot those things and see if, those buckets change over time. So what happens when we aggregate the data that we had for that last region? We get this. So it's better. This is buckets of 1,000 for Passmark, so looking at 30 different disparate CPU groups. So you can see some pretty good stratification there. Most of the graphs are flat, except for that crazy blue one up top. That one's my fault. So that's actually all the null CPUs that I haven't got the latest Passmark data from. We've just updated our pipeline for this data internally, so this is generated weekly now. So there'll be less of that happening. So if we get rid of that, we ignore it. We don't like bad data. This is what it looks like just with the Passmark values, bucketed by groups of 1,000. There's very distinct layers here. You can see, at the top, there's 0. That's the slowest CPUs, and these are slow CPUs. So you've got players that are playing at 40 milliseconds plus per frame. All right? Some of those are bots. We have bot farms that come from all over the place, where people will write systems to play the game. They're not hacking the game, they're actually playing the game to get XP to do stuff. And so some of the data, you kind of need to figure out whether this is valid players or it's some weird outliers that are causing problems. So you can see that as the Passmark values increase in value, they get faster and faster and faster. And that's what you would expect. This intuitively makes sense, and this is what you would expect from your performance data. So GPU Passmarks are the same. You can see that stratification, and that they're pretty flat. So you could see that if we had a performance degradation from one patch to the next, we should actually be able to see this quite accurately. So let's throw away most of the data here and just look at 3 different Passmark values. This is CPU Passmarks of 13,000, 17,000, and 22,000. So you can see it's pretty flat. Again, you can see that the domains shrunk to match what we're looking at here. If you look at the GPU at the bottom, you can see that the last patch was a little bit slower than the patch before. So, and you can see that the CPU is also fractionally slower. So you could say, well, okay, maybe what we're looking at here is we're doing more stuff on the GPU, or something's changed on the GPU, which has caused a slowdown across the board. So there's still a bit of variation. Let's drop this down just to one Passmark value. This is 17,000. So you can see quite clearly here the jump in GPU time per frame and the corresponding jump in CPU time per frame. So 1215 averaged around about 7.5 milliseconds per frame, and 1216 is about 7.6. So we're measuring 0.1 millisecond variation in time, which is pretty good. We were seeing 5 milliseconds plus before. So now we've managed to extract our data down. We've got something that we can compare, because we want to compare apples against apples, so that we know that what we had before is the same thing we're comparing against now. So yeah, we'd guess here, okay, something's changed on the GPU. So this is 13K, looking at a similar profile. So when we're looking at aggregating our CPU and GPU into these buckets of benchmark, performance equivalent data sets, what would we expect to see if we look at this data across different regions? If we're comparing, say, North America to Brazil, to Turkey, to Russia, to wherever, would they be the same? You'd hope so. They're not. So this is currently an unsolved problem for me. We do have variation, and there are a couple of possibilities that could be causing the variation here. One is network. When you're getting more disconnects and you've got a more faulty network, you're getting more packets having to be resent, you've got catch-up, you've got all sorts of stuff happening there. Whenever I do a talk, I end up going down rabbit holes looking at the data that I've got, trying to figure out, am I lying or is this true? I end up separating these by the amount of memory on the actual CPU. And there's a very distinct difference between machines with 16 or 32 gigabytes of RAM compared to those with 8 or 24. So it could be a memory issue there. So, but yeah, so there is a lot of data you can dig into here, and you can spend forever trying to understand exactly how and why these different systems are slower or faster in different regions. It could also be that, in some of the other areas that the pass mark value is closer to, it's the same bucket, but it's closer to the slow end or the fast end. Lots of experiments that could be done there. So then what we can do is end up putting all this data up in something like Tableau. Tableau is great. It's not a cheap solution, but it's a great solution for investigating data, particularly for people that aren't really good at doing SQL like me. When I went to uni, I swore I'd never do database programming. I'm actually kind of enjoying it. The data is interesting. So this is 2 months of data. You can see up on the top left, you've got your CPU and GPU, and bottom right, you can see the bar graphs of the different pass mark buckets. So you can actually click on those, filter by them, and actually see, are the min-spec machines getting slower? Are the high-spec machines getting slower? You can actually change all those around. You can look distributions, what are the most common sets of CPU and GPUs that are being used. You can look at counts of games per combinations of CPU and GPU. We're also plotting memory usage up there. You can see to the right-hand side, top right, there's a sudden change in the amount of memory that's being used for TFT. That's with a new set being released. The drop before that was them trying to prepare for the release of new data by saving memory. So you can see they got better and then made it worse again. So being able to see that is important, because particularly when you're looking at lower spec devices, you don't want to use more memory. You're heavily constrained. You want to know when you're using more memory than you should. We also look at load times and time to get in a game, and there's a whole lot of other information that we collect as well. But this is just like the landing page. So this is 2 years of data. So you can see a slow increase in the cost of the average of frames on CPU. You can see on GPU, we changed to DirectX 11 from DX9. So you can see a sudden change there in performance, particularly for memory. The way memory is being reported was also changed. So you can see a progression over time. You can see our loading is slowly getting better. But yeah, so this is great, right? We can see all this information. We can see when things have gone bad. What do we do now? It's got worse. Do we know why? What do we do about this? Do we have enough information to identify the cause of the problem? Yeah, maybe. Like we said, maybe it was a GPU, but what change on the GPU caused that? We could go through all the changes that happened in the last 2 weeks before it was released and do a binary diff and compile it and run it, and it's like, yeah, nah. So more data would be better. So what data is missing? What do we need to be able to identify the problem areas? Subframe performance is something that we collect. We divide the frame up into a whole lot of contextual sections. We have AI, we've got render and physics, particles, game object, update. Anything that's a significant portion of the frame, 10% or so, we we collect that information. So not just the measurement of time, but also counters. So certain things, if there's lots of them, they will cause the game to slow down. So measuring that will give us more information to help us identify the causes of the slowdown within a particular section. So we could have an increase in game objects, which may have a side effect of creating more particles. And if we plot the number of game objects, we can see that sudden change. And we can say, well, that's what's caused the increase in the particle time. So we can plot all this stuff as well. All right, we can collect the data in the game, and we can send that off to our massive data collectors, and we can filter it by CPUs and GPUs and sections, and then we can say, the game object update has changed from this to that, and that's kind of useful. It allows us to narrow down where the problem could be. So we can plot these as well. So these, I call them RPDs, it's just Riot profile data. Very ingenious. So you can see the game world is like the game object update. That's been getting a little bit slower as time has been going on here. So that would be something that's like, okay, we know that the next thing that we need to optimize is our object manager stuff to ensure that that's a lot faster. That's our biggest bottleneck at the moment. So we know that. So when we need to get some performance back, we can just jump into that and fix it. I'd love to fix it. So not just the averages, you can also look at the maxima. So you can see here we've had problems with, initially we had some HUD issues that were causing some massive spikes. Knowing that things are really slow and in which section they're really slow, even if it's not every frame, collecting those maxima is valuable as well. It's great for identifying outliers. So you can see here, you'll see a slowdown and then it'll be fixed for the next patch. So we've been pretty good at identifying these things and actually fixing them. So now we can attribute performance changes to a section of code globally. For example, we can say particle update slowed down in the last patch, or UE rendering has improved dramatically. It helps with budgeting, performance, and identifying areas for optimization. We can now look at trends and identify future bottlenecks, potentially. So, and don't forget, you can slice and dice by region and mode and CPU spec, GPU spec, all sorts of things. But what about the players? An individual player is complaining about having performance issues. How do you help them? This is not individual data. This is global data. We're seeing trends overall. So when a new driver jumps out and it's suddenly slower, how do you identify that? So how can we triage these very specific performance issues, like the Rakan one that we saw? Well, remember, we collect all the subframe times during the game. At the end of the game, we can actually save them out. So we will then have a performance signature for the entire game. So I wrote a little system that is zero intrusion. It stores maybe 12 times across a single frame and puts them in a little cache. And then at the end of the frame, it quantizes them down and sticks them in an array. So over an entire game, you're looking at maybe 2 megabytes of data. And at the end of the game, it goes through, it processes all that data, works out your medians and your averages and your max and min, all that information, sends some out to some of our collectors, and also saves it. So when a player complains that their game lagged and it's our fault, then we can actually ask them, say, hey, can you send us a file that's in your game directory called an RPD, and we can grab that and we can actually have a look at it. And we can see for every single frame how much time was spent in each of the sections that we're concerned about. So I wrote a little JavaScript thing to have a nice, easy web page that any of our QA or programmers can just drop an RPD file in there, and it gives us this, and we have histograms and all sorts of data stuff that we can do. Anything I want to add to it, I just write it, add it to it. So you can see here, you can select a small section, and that looks like a spike. There's a slowdown there. So we can zoom in on that and see what's kind of going on. The black line's like an average over 2 seconds, I think, either side. So you can see the blue line at the top is the actual total frame time. So if we drop that off, we can look at what's happening underneath that that's attributing to that. And if we zoom in on that, we can see, okay. We can hover and we say, okay, we've got your GPU taking a fair bit of time. RL is our render time. That's taking a bit of time. But we're also looking at, see, I should have worn my glasses. The HUD is taking some time, but also our particle simulations jumped up. So likely what's going on here is we have some extra particle simulation happening, which is causing more time to render, which is impacting our render time on CPU, as well as our GPU time. So we can look at that and say, okay, this is what's going on here. We could grab a replay if we wanted to, and actually identify that that's exactly what's going on, and very accurately measure and profile what's going on with that. You'll notice at about 505 seconds, there's a little square bump as well. That's HUD. That's a little HUD thing that's popping up and doing something. This gives us a way of quantifying exactly how much time some of our HUD stuff is taking. And this is on a player's machine. We can see exactly what they're doing. It also allows us to see when they're struggling with other things running on their PC. You'll start to see lots of noise. We also measure the system load, so we can see that, okay, they're running at 75% on their CPU. That's not our fault. They shouldn't be streaming porn while they're playing League. It's going to slow things down. So remember this bug report at the beginning, all right? This corresponds to this. This is some actual data from players who are having this particular problem. Now, you can see it at the bottom. That's the system load. You can see it jumps by a bit. Now, this is not because the player's doing something. This is indicative of across a number of players, and it's across a number of different regions, and it's an arbitrary amount of time, which is 5 to 10 minutes into game, and it goes for a few minutes at a time, but it always looks like this. I mean, humans are very visual, so being able to see this in a plot is so valuable. You can start to match it with other things. So what's going on here? It looks like, my initial guess is that it was an AMD driver issue for their particular set of GPUs, because Epic had reported the same thing, and it was slowing down Fortnite, and so their recommendation was to roll back to an earlier version. So this is bad, but we need to be able to identify this as a problem so we can talk to the driver manufacturers and say, hey, we have evidence of a problem that your drivers are causing, and normally they're pretty happy to help. Helps being a massive company with lots of players too, of course. So it happens in League, it happens in TFT. Like I said, it seems to be certain combinations of AMD hardware. So this is from the latest patch. So in doing this talk, I've started to engage with the players and say, hey, yes, there's something going on, send us more information. Most players love to help. Some don't trust game devs. I've had players refuse to give me their RPD file because they're afraid that I'm stealing information from them, which is fine, it's fine. But other players will do whatever they can to help because they want to play your game. So it's up to you to help them. So they are complaining about your game because they want to play your game. You know, these types of performance breadcrumbs that you can leave on their devices. I mean, we collect some of that data. We have ways that we can identify individual games that have had bad performance, and we can automatically send that data. But sending 2 megabytes of data per game is not a good idea when you've got hundreds of millions of games going on. So we're very selective. We can turn off different regions. We can randomly get people to send data, and then we can start to dig into those things. So that's great. We're now able to grab some client information. We can see what's going on. The other thing with this type of data is that we don't have instrumented game actions. We don't see the abilities that are being cast here. On the server side, we do. Because we don't want raw strings lying around in our client. We don't want any ways for hackers to identify what's going on easily. They'll do it anyway, but we want to make it as hard as possible. So don't forget the server, okay? Servers is so important. I know when I started at Riot, I just focused on the game client. I need to make that run as fast as possible. That was the most important thing. But the game server and the hardware they run on is so important, and also a massive cost. So keeping an eye on what's going on with those. Also, they have the possibility of causing the most impact to our players. If your servers are overloaded, everybody's having a bad game. Doesn't matter how fast their machines are, doesn't matter how well optimized the game client is, they're not having a good time. So you need to report and store as many metrics as you can. You want your frame time, your sub-frame times. Relevant counters are also critically important. Your system stats, so your system load is a hard drive reading and writing. You want to look at file I/O, network traffic. Network traffic is great because, not all of the problems you're having are because of your code. You also got bad actors that are trying to DDoS you. And some of this information can help you identify those problems as well. This allows you to do capacity projections. So you can say, okay, we know that when we hit 70% CPU load, we start getting performance degradation. So because of that, we know that at 70%, we have X number of servers running with X number of players. We can artificially limit that to just before then so that we're not seeing any performance degradations, and we can stop it before we start to overload. We also know that if we're expecting to have 10 times as many players for the next patch because something really important is being released, we can have the capacity ready to go. We know exactly how much we need. And so we can cost against it. So this allows us to prepare for scale. Reduces our chance of overloading. So a lot of this information can be reported to a lot of building services, third-party things like New Relic, that allow you to, in real time, send information that can be plotted. New Relic provide a whole lot of low-level stuff for your system load, and we send extra metrics about number of players in games, disconnects for different regions. If individual CPUs are overloading, we can catch that, and we can actually have alerts that go to our network operations center, and they can figure out if that's important or not. This is disconnects, so we can see if there's a sudden rise in disconnects, which could be client crashes. It could be there's a cyclone in Brazil, and they've taken out some of the infrastructure. So actually watching the news while they're looking at this data is actually relevant to see if there's disasters that are occurring, which has happened before. We can see what's going on here, and we can identify problems that we need to address and address them. So again, this is more server information, players in game. We can see sudden dips. We don't want necessarily we want to have this many games in action. We're looking at changes over time because there's a circadian rhythm per region, and even globally, you can see all the day-night cycles occurring. Having this information, being able to report it and collect some of this over a long period of time is so valuable. So, performance metrics. The performance data is more than just performance. Your goal's not just to quantify changes in overall performance, but to identify individual cases of bad performance so you can fix them. If your data doesn't help you pinpoint the issue, it's not good enough. So start with the basics. Collect your frame times, your memory usage, CPUs, GPUs, and then try and use that to triage issues. And if you can't figure out what data you need to add it, iterate. So, like I said, collect common types of hardware that your players use. That's useful information. Your screen resolutions. Do people play in 16:4 or is it 1:1? How do they play? What do most people do? Where and when your players play. That's also relevant. It can help you focus on the most common devices, and you can build and optimize for those. Or you can aim at some of the more underutilized devices that are quite common that you're not seeing players on, so you can identify that maybe you need to make your thing better so that you can get more of those players on board, broaden your audience. So, in summary, figure out what good enough is. Measure and collect metrics that indicate the level of good enough achieved. When games are not good enough, figure out what you need to add to triage the issue. And then add that data to the metrics that you collect. And then go back to 2. It's a constant, trudge. I mean, we're getting better at it at Riot, but there's still like something goes wrong. It's like I don't know. It's just too hard to find sometimes. So yeah, profit is the final bit you get. Exactly, you never reach profit. So, all right, so look, thanks for listening. It's been a pleasure talking at GCAP again. If you have any questions, the microphone's ready.
Hello. When it comes to analyzing frame data, are there any tells when it's a result of network latency versus the hardware of the user?
Probably the best way to tell that is actually looking at some of the network statistics that come along with it. So you can look at, okay, when was the last time I got a packet? Or how much data have I got in this frame? That's data I don't currently collect, but it's on my list of things to collect. That would give us an indication of bad network connection. Because like I said, I suspect that some places like Brazil have worse network connections, which is leading to the bad performance. If we know that, we can start to address that and optimize for that problem. Some of that, we have a network section as well, but that's not just network, that's reacting to the network events, and it's actually running some Lua script and other things which also can cause slowdown. So it could be bad scripts that are causing the problem, but looking at the different regions and seeing if there's a difference in that particular section of the frame would help us to identify that maybe that is the cause. But I think collecting actual network data and network errors per frame would be good. So I could actually have the time that I have events that I can add to that data as well. So I could chuck in a network error occurred here. So I could see on the graph when they occurred, and you could see when they were causing problems.
Thank you.
How much do you find that changes in gameplay factors like shifts in the meta skew your data collection? And do you collect that data alongside this, or is that as a separate analytics pipeline?
Yeah, the meta is like a separate analytics pipeline. We see this dramatically with TFT because it's whole changes of sets. So the gameplay changes dramatically, the arts change dramatically. So that's a very dramatic changes from patch to patch. As far as in League is concerned, not so much. It's a fairly uniform performance across the whole thing, no matter how you're playing or where. So yeah, not for League, yes for TFT.
Given the really fast patch cycle in some cases, like 2 weeks, what would you say your time split is between things that QA catches and things that happen on live when you're fixing?
We have a lot of tools built into the game that allow a QA to identify these things very easily. So we can pop up a debug performance window that gives us all the frame times, and you can dig down into frame graphs of individual frame information. A QA know how to use these so that when they do see a spike, they can report that very early on and provide us with enough information to easily triage it. The stuff that does slip through is usually quite tricky to find. We've had some easy ones which have got through QA, but they've been small enough. And like we had one where we actually were losing 2 milliseconds per frame, and we didn't pick it. So, because your frame rate's not changing that much, and it was like 1 millisecond, and then a week or so later, another millisecond dropped. And that kind of slipped through because there was no spikes. And it kind of felt okay, but yeah, it was a stupid typo, basically. Where a stall was supposed to be for 0 seconds, but it was actually stalling for 1 millisecond, which happened twice. So,
thank you for the presentation. It's not trivial to me when you say that you have fixed a problem. So is it localization based? Because you said that for Brazil there are some network issues, like for some other country it might be some other sort of issues. How are the instances between the players if they play internationally different?
We actually have had performance issues due to localization, because we are dealing with different assets. in different regions. There are limitations on, blood, for example. Fonts are different. The way we handle text is different. There's more processing for some of those, and bugs in some of the localization stuff for rendering that we've written have caused issues as well. As far as the difference in performance between, say, Brazil and Korea, we've not really addressed that as a major thing that we need to fix. Because a lot of that is just a significant hardware difference anyway. Just through different economies, different socio-economic groups who can afford the better hardware tends to be places like Korea or North America or Japan. So yeah, as far as the different region level problems, that all comes back to the same teams basically. It's not dealt on a per region case.
They should be serving lunch outside, but we have the room. No one needs the room if we want to take some more questions as well.
Yeah, sure. If you want to come up and chat, happy to talk.
I have one other question. You kind of group all your CPUs like into different buckets.
Yeah.
And you do that using passmark data.
Yep.
Is there a reason why you use passmark data and not your own internal benchmark, for instance? Like on startup of the game?
Yeah, we used to have some of our own internal like cycle counting and performance, but it's not clear that our internal benchmark that we could do on startup would be more accurate than collecting data from some other third parties. So it was mainly convenience.
Okay, yeah, fair enough.